Welcome back. Staying ahead in tech, especially with AI exploding and data needing constant protection, it's critical for everyone in IT and leadership roles.
Absolutely. And that's why today we're really digging into something important. Google's latest, their 7th gen TPU, this thing called Ironwood.
Right. So our mission here is to cut through the noise, pull out what really matters about Ironwood for you, especially thinking about data protection and just the sheer scale of AI now.
Exactly. We want to connect the dots between this new hardware and the challenges you face daily.
And this isn't some far off future tech. Google just unveiled it, what, April 9th? At Google Cloud Next?
Yeah, just this week. And they're saying Google Cloud customers can get their hands on it later this year.
So understanding it now is pretty key.
Definitely. It's more than just a speed bump. It feels like a strategic move in how AI infrastructure is being built.
Okay, good point. And hey, before we dive deeper, just a quick mention of Stonefly. They provide really essential products and services for folks like our listeners, managing those complex IT setups and making key business decisions. We'll circle back to them later.
Sounds good. So Ironwood, what's the main headline? What makes it different?
Well, the big shift is focus. Google's previous TPUs, great for training models, the learning part. But Ironwood, this is their first one specifically optimized for inference.
Inference. So running the models, actually using them.
Exactly. Putting the AI to work, making predictions, recommendations, finding insights, that's inference.
Okay, that makes sense. I saw Google Cloud's VP, Amin Badat, called it their most powerful, capable, and energy-efficient TPU yet. And he specifically said it's to power thinking, inferential AI models at scale.
Thinking models at scale, that really sums it up, doesn't it?
It does. And you have to see
Yeah.
this in context, right? The AI chip market is, well, intense.
Oh, yeah. Nvidia is obviously huge, but you've got Amazon with Trainium, Inferentia, Graviton.
Microsoft's got their Mayo 100 on Azure. Everyone's building their own specialized stuff.
So Google zoning in on inference with Ironwood is quite specific.
It really is.
Yeah.
It suggests they see a massive bottleneck or maybe opportunity specifically in deploying these trained models efficiently.
Okay, let's get into the nitty-gritty. Performance. What are the numbers looking like?
Well, Google's internal benchmarks put a single chip at 4,614 TFLOPs peak compute, which is, a lot.
A lot, yeah. But what else stands out?
The memory. That's huge for inference. Each chip packs 192 gigabytes of RAM.
192 gigs on
Yep.
one chip.
Yep. And the bandwidth is nearly 7.4 terabits per second.
Okay, why is that so important for inference specifically?
Well, think about it. Larger AI models, huge data sets.
Yeah.
Inference needs quick access. Having that much fast memory right on the chip means the processor doesn't have to constantly go fetch data from somewhere else.
So less waiting around for data. Keeps things moving faster.
Exactly. Reduces latency, avoids bottlenecks. It's all about keeping the data super close to the compute.
Got it. Now, I also saw a mention of something called sparse core. What's that about?
Yeah, the sparse core. It's a specialized part of the chip that's been enhanced. It's designed to be really good at handling sparse data.
Sparse data. Like data with lots of zeros or empty values.
Kind of. Think about recommendation engines like suggesting clothes online or advanced search ranking. Those often involve sparse data structures. Sparse core is optimized for those workloads.
So it speeds up things like recommendations.
Precisely. And interestingly, Google's apparently pushing it beyond just AI into things like finance and scientific computing too. So it's getting broader application.
Interesting. And there was something about the architecture minimizing data movement inside the chip itself.
Yeah, that's a key design principle. The less distance data has to travel, even within the chip, the less time it takes, that's lower latency, and the less power it uses.
So faster and more energy efficient just from the layout.
Essentially, yeah, it's a core part of designing high-performance, efficient processors today.
And Ironwood isn't just a chip you buy off the shelf, right? It fits into a bigger picture.
That's right. It integrates into Google's AI hypercomputer. You can think of that as this big modular computing system in Google Cloud.
A system, okay.
Yeah, it emphasizes that it's not just about one chip, but how lots of them work together, hardware and software, orchestrated for these massive AI jobs.
They mentioned a couple of configurations, like a 256 chip setup and then a monster 9,216 chip cluster.
Yeah, those numbers are staggering. That 9,216 chip one, they're claiming 42.5 exaflops.
Exaflops, how does that compare?
Well, just for perspective, the El Capitan supercomputer, one of the world's biggest, is around 1.7 exaflops. So this cluster is potentially over 24 times more powerful.
Wow, okay. That's serious compute power for AI.
It really demonstrates the kind of parallel processing capability they're aiming for.
How do you even get that many chips talking to each other effectively? Must need incredible networking.
Absolutely. That's the ICI, the inter-chip interconnect. Ironwood boosts that bandwidth to 1.2 terabits per second bidirectional.
Which is faster than before.
Yep, about 1.5 times the bandwidth of the previous gen, Trillium. That speed between chips is vital when you're spreading a huge task, like training or large-scale inference, across potentially thousands of them.
Makes sense. And the software piece must be just as important, right? To
Yeah.
manage all that.
Oh, completely. Google DeepMind's Pathway software stack is key here. It's designed specifically to distribute the work efficiently across all those TPUs. You need sophisticated software to actually harness the power of tens of thousands of these things working together.
Okay, so pulling this all together. Powerful inference chip, tons of memory, fast connections, smart software. What does this actually mean for our listeners, the IT pros and decision makers worried about data protection alongside AI?
Well, first off, the raw performance and efficiency boost means organizations can handle more demanding AI workloads. And these workloads, almost by definition, chew through vast amounts of data that needs protecting.
Right, so better AI performance often means more data being processed, increasing the protection challenge.
Exactly. And the focus on inference means AI models can be deployed faster and more efficiently for all sorts of business uses. Fraud detection, personalization, analytics.
Which again likely means more systems touching sensitive data.
Precisely.
hmm
So as AI becomes more embedded, your data protection strategy needs to be that much more robust and scalable to keep pace.
You mentioned efficiency earlier. The power savings sound pretty dramatic.
They do. Double the performance per watt compared to Trillium, and almost 30 times better than their first cloud TPU from back in 2018.
That's huge for cost, right? Especially with energy being such a concern.
Absolutely. Running massive AI jobs is power hungry. Making it more efficient per watt saves money and, helps with sustainability concerns. Plus, they mentioned advanced liquid cooling, which helps sustain that performance without overheating.
And that jump in memory, 6x the capacity, 4.5x the bandwidth versus Trillium, that directly helps with managing bigger models and the associated data, doesn't it?
It's crucial. Larger models often mean better accuracy or capability, but they need the memory and bandwidth. This allows handling those bigger data sets more effectively, which impacts both the AI processing and how you manage and secure that data flow.
It's wild to think what this enables. They mention models like Gemini 2.5, AlphaFold.
Yeah, those are already state-of-the-art models running on current TPUs. Ironwood is built to power the next generation of those thinking models, potentially leading to breakthroughs we haven't even conceived of yet.
Which really circles back nicely to our sponsor, Stonefly. Because as this AI infrastructure gets more powerful and complex, managing and protecting the underlying data becomes, well, even more critical.
Couldn't agree more. The demands are just scaling up incredibly fast. Having the right tools and strategies for data management, protection, and accessibility is no longer just important, it's fundamental.
And that's where Stonefly comes in. They offer products and services specifically designed to help IT leaders and businesses navigate this. Making sure your data is secure, available, and managed effectively, even as you adopt these powerful AI technologies.
Yeah, it's definitely worth exploring how solutions like those from Stonefly can underpin your AI strategy, ensure you have that solid data foundation. They really focus on supporting organizations dealing with these exact challenges.
Okay, so wrapping up. Ironwood looks like a major step, particularly for AI inference. Big gains in performance, memory, efficiency, all highly relevant if you're deploying AI.
Definitely, it addresses a key part of the AI workflow.
So the final thought for everyone listening. With AI demanding more compute and generating more data than ever, how fundamental will tech like Ironwood, paired with really smart data protection and management strategies, become? Not just for efficiency, but for staying competitive and ensuring AI is used responsibly in your organization.
That's the key question, isn't it? How do you balance harnessing this power with managing the associated risks and data complexities? Something everyone needs to be thinking about for their infrastructure roadmap.
A lot to consider. Thanks again for joining us for this deep dive.
My pleasure. Until next time.